A very good morning to all student members who have gathered here. I welcome you all for the second module in machine drawing. So today we are going to discuss about fits and tolerances in machine drawing. So let us see the objectives of fits and tolerances. The main primary objective of using fits and tolerance in engineering application is to confirm whether we have prepared a proper assembly fit joints or not. So the main purpose of fits and tolerance is to have some minimal variations in order to simplify the manufacturing operations with comfortable and ease. So with this few keynote information, now let us get into the main theme of presentation. So we are now going to discuss about the importance of limits and fits in assembly drawing. So limits, fits and tolerance, these are the key fundamental concepts in engineering and manufacturing dealing with permissible variations in the size as well as the geometry of parts to ensure proper functionality and interchangeability. So using these concepts, we can able to maintain the value-added flexibility in connecting or assembling the machine parts in a more flexible way by avoiding inconvenience during the assembly operation. What are the primary needs of limit, fits, and tolerances? The first thing is no two exact parts cannot be produced with the identical measurement with the zero tolerance. So practically that is not possible for any manufacturing process. You take any production process, so every part is maintained to have certain amount of variability that will exist in quite nature. That variation is called as a tolerance zone. Usually the variability arises from improper adjustment of machines, poor error, tool wear, or sometimes defective raw material. Here, examples given as follow. A shaft has to be manufactured to a diameter, say 40 mm plus or minus tolerance 0.02 mm. So what does it mean exactly? So the shaft whose basic size is considered to be 40 mm. If it will be acceptable if its diameter lies between the limit of size, say upper limit 40.02 mm and lower limit 39.98 mm. So the permissible allowable tolerance is considered to be 0.04 mm. By taking difference between the upper limit and lower limit dimensions, so we can maintain this much amount of tolerance 0.04 mm. If it is far below, the part cannot be accepted. It is considered to be a poor quality machine part with allowable error variation. So it should lie within this permissible variation 0.04 mm. So now let us go to the next concept, tolerance. So the tolerance is nothing but the variation permitted on a given dimension of the machine part is called as a tolerance. Sometimes it is defined as the difference between the higher limit and the lower limit. So below there is an example. Let us see what is the example correlated here in connection to the definition. Say, consider a 10 mm nut for a 10 mm bolt. Here, due to some human error and machining error, the diameter inside it becomes 9.98 mm. So therefore, the nut will not exactly fit into the bolt. So the joint will be spoiled. So here we have to introduce tolerance zone in order to avoid this type of error. So what are the different types of tolerances? Unilateral and bilateral tolerances. So unilateral tolerance. So here the tolerant distribution will be focused only on one side of the basic size of the part. Whereas in bilateral tolerance, the tolerance distribution lies on either side of the basic size of the part. So according to the Taylor's gauge principle, now let us understand the basic meaning. What is maximum and minimum metal conditions? So let us take a shaft and hole system as a reference model. Consider a shaft of having a dimension 40 plus or minus 0.05 mm tolerance and a hole dimension 45 plus or minus 0.05 mm. See, based on this dimension, say for the shaft, they have given the maximum and minimum metal condition limit. Similarly, for the hole size, they have given the maximum and minimum metal limit condition. What it exactly states, so using this maximum and minimum metal limit condition, we have to ensure whether two assemblies are comfortably fitting with each other or not. So now let us see the next information in continuation to the previous topic. So fits, importance of fits in assembly drawing. Fits are nothing but the assembly conditions between the hole and the shaft. So it is defined as the degree of looseness or tightness between the two assembly parts when it is supposed to join together. So here there are different classification of fits: clearance fit, interference, and transition fit. Let us see all the three. So what is clearance fit? So this type of fit has a hole and shaft in which there are two type of limit, upper limit and lower limit. So inside the hole, along with this, both will come in picture in the tolerance, that is upper limit and lower limit. So in this type of fit, the tolerance zone of the hole and the tolerance zone of the shaft will have some clearance gap between them as shown in the figure. Say if the hole size is larger than the shaft, we can make the shaft to freely rotate inside the hollow part feature. So in that aspect, we can call as clearance fit. It is called as a loose fit. Next one is an interference fit. Here the size of the hole is minimal compared to the size of the shaft. So here we require more excessive force to insert the shaft into the hole. With the help of the hammer or sometimes using hydraulic press, we can able to forcefully fit the shaft into the hole. So this type of joint we call it as a tight joint or press fit joint, interference fit. The third one is a transition fit. It is a hybrid or a combination of both interference and clearance fit. So in this type of fit assembly, the tolerance zone of the shaft lies between the lower to the middle of the tolerance zone of the hole. This means that the hole is smaller than the shaft diameter. So you can able to see the pictorial representation of the transition fit on the other side of the information. Next one is importance of production drawing, preparation of production drawing in assembly component of various machine parts. So normally production drawings are said to be the detailed technical information or a document used in final manufacturing to communicate the various information that are required for manufacturing a part or an assembly joint. So the production drawing will be normally represented in orthographic view with the dimensions, tolerances, then material specification, surface finishes, etc. These drawings are highly essential for ensuring whether the parts are manufactured with better accuracy and consistently maintained according to the design specifications. How to read a production drawing of a part? So with the knowledge of geometrical dimensioning and tolerancing. So what it exactly? Geometrical dimensioning and tolerancing is a system which is used to define the tolerance of various machine parts. Say it is a symbolic language used in engineering drawing. Normally the computer generated 3D model. So if you want to define the allowable variation in the part feature geometry, so we can use this kind of geometrical dimensioning and tolerancing to show the variation size of the different parts. The production drawing is nothing but the complete set of drawings that have a detailed description on the manufacturing process as well as the importance of assembly of various designed products. The main purpose of production drawing is to define the size, shape, location, as well as the production of the component. This will be a guidance for the machine operator, even line worker and supervisor. Here I have given some pictorial example of a production drawing for a flange coupling hub. Here are some of the standard notation, the symbols that are used. So this will serve as a benchmark for the production line supervisor while preparing the parts. So with this information, I conclude the following module number 2, what we have discussed. So first one, we saw about the basic introduction to assembly fits and tolerances, different types of fits and tolerance in machine component. And last one, importance of production drawing in machine component. So with this information, I thank all the members who have gathered here. We will meet in the next occasion with another topic. Thank you once again.